Electrical Code, specifically National Electrical Code Article 314.17c, mandates that all unused openings in electrical boxes must be closed. This requirement is in place to prevent the entry of moisture, dust, debris, or other foreign materials that could compromise the integrity and safety of the electrical system. The code does not differentiate based on the location of the opening. Therefore, unused openings at the bottom of a box are subject to the same regulations as those on the sides or top. An open hole, regardless of its size or position, presents a potential pathway for contaminants and can increase the risk of electrical hazards. When addressing an unused opening in an electrical box, several options can be considered to achieve compliance. Firstly, it's important to evaluate the size and nature of the opening to determine the most appropriate solution. If the opening corresponds to a standard knockout size, a knockout closure or knockout seal can be used. These closures are designed to fit snugly into the knockout and provide a secure seal. They are typically made of metal or plastic and are available in various sizes to match standard knockout dimensions such as 1/2 inch, 3/4 of an inch, and 1 inch. Secondly, if the opening is smaller or irregularly shaped, alternative methods may be necessary. One option involves using electrical tape to seal off the opening. While this can serve as a temporary fix, it may not be considered a permanent or fully compliant solution by all inspectors, especially if the tape is likely to deteriorate or become dislodged over time. For a more robust and durable solution, applying a small amount of silicone sealant around the opening can effectively fill the gap and create a moisture-resistant barrier. The sealant should be compatible with electrical applications and rated for the temperature range it will be exposed to. Make sure the sealant is applied neatly and evenly to completely cover the opening. Thirdly, in situations where the existing box has multiple unused openings or if the available solutions are not suitable, it may be necessary to replace the box with a new one. When selecting a replacement box, consider the number and size of the required conduit entries as well as the overall dimensions of the box to ensure it can accommodate the existing wiring and connections. Choose a box made of appropriate materials such as metal or plastic, depending on the application and local code requirements. When working in retrofit situations, closing off unused openings can present unique challenges, especially when access is limited or the existing wiring is difficult to manipulate. However, it is crucial to address these openings to maintain compliance with the National Electrical Code and ensure the safety of the electrical installation. In hotel installations or similar commercial settings, it is particularly important to adhere to electrical codes and regulations to protect the safety of guests and employees. Even if other boxes in the same facility have been left with unused openings, it does not excuse non-compliance in subsequent installations or repairs. Each electrical installation should be evaluated and addressed independently to ensure it meets the required safety standards. Failure to close off unused openings in electrical boxes can have several negative consequences. Firstly, it can result in a failed inspection, which may delay project completion or require costly rework. Secondly, open holes can allow moisture, dust, and debris to enter the box, potentially leading to corrosion, short circuits, or other electrical problems. Thirdly, exposed openings can pose a safety hazard to individuals who may come into contact with the electrical system, particularly if live wires are present inside the box. In summary, addressing unused openings in electrical boxes is an essential aspect of electrical work that should not be overlooked. By following the recommendations outlined in National Electrical Code Article 314.17c and using appropriate methods to close off these openings, electrical contractors can ensure compliance with safety standards, prevent potential hazards, and maintain the integrity of the electrical system. When dealing with specific scenarios or complex installations, it is always advisable to consult with a qualified electrical inspector or engineer to ensure that the chosen solution meets all applicable code requirements and safety standards. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations in the United States. It is developed and updated every 3 years by the National Fire Protection Association, or NFPA, to address evolving technologies and safety concerns. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. It serves as the foundation for electrical codes and regulations at the state and local levels, and it is widely adopted by electrical contractors, inspectors, and engineers to ensure safe and reliable electrical systems. Article 314 of the NEC specifically addresses outlet, device, pull, and junction boxes, conduit bodies, fittings, and handle enclosures. This article provides detailed requirements for the selection, installation, and use of these components to protect conductors and prevent electrical hazards. Section 314.17c focuses on the requirement to close unused openings in boxes and fittings. The purpose of this requirement is to prevent the entry of moisture, dust, and other foreign materials that could compromise the integrity of the electrical system. By closing off unused openings, the risk of corrosion, short circuits, and other electrical problems is reduced, and the overall safety of the installation is enhanced. Several methods can be used to close unused openings in boxes and fittings, depending on the size and shape of the opening and the specific requirements of the installation. One common method is to use knockout closures or seals, which are designed to fit snugly into standard knockout openings and provide a secure seal. These closures are available in various sizes and materials to match different knockout dimensions and environmental conditions. Another option is to use threaded plugs or caps, which can be screwed into threaded openings to provide a watertight or dust-tight seal. For smaller or irregularly shaped openings, electrical tape or silicone sealant can be used to fill the gap and prevent the entry of contaminants. However, it is important to select materials that are compatible with electrical applications and rated for the temperature range they will be exposed to. In some cases, it may be necessary to replace the existing box or fitting with a new one that has the appropriate number and size of openings for the intended application. This may be required if the existing box is damaged, corroded, or does not meet the current code requirements. When selecting a replacement box, it is important to consider the type of wiring method being used, the number and size of conductors, and the environmental conditions to ensure that the new box provides adequate protection and support for the electrical system. It is also important to follow the manufacturer's instructions for installation and use of boxes, fittings, and closures to ensure that they are properly installed and will perform as intended. This includes tightening screws and connectors to the specified torque, using appropriate tools and techniques, and inspecting the installation to verify that all components are properly aligned and secured. In addition to the requirements of NEC Article 314, other sections of the code may also apply to the installation of boxes and fittings depending on the specific application. For example, Section 314.27 addresses the support and mounting of boxes. Section 314.28 covers the sizing of pull and junction boxes, and Section 314.40 provides requirements for the use of non-metallic boxes. It is important to consult all applicable sections of the NEC and any local codes or regulations to ensure that the electrical installation complies with all requirements. When working on electrical installations in commercial or industrial settings, it is especially important to follow all applicable codes and regulations to protect the safety of employees and customers. This includes providing adequate training for electrical workers, using appropriate personal protective equipment, and implementing lockout/tagout procedures to prevent accidental energization of equipment. It also includes conducting regular inspections and maintenance to identify and correct any electrical hazards before they can cause an accident or injury. In summary, closing unused openings in electrical boxes and fittings is an essential aspect of electrical safety and code compliance. By following the requirements of NEC Article 314 and using appropriate methods and materials, electrical contractors can ensure that electrical systems are properly protected and that the risk of electrical hazards is minimized. It is important to stay up to date on the latest code requirements and to consult with qualified electrical inspectors or engineers when necessary to ensure that all installations comply with applicable standards. One additional point to consider is the impact of environmental factors on electrical installations. In areas with high humidity, excessive moisture, or corrosive substances, it is especially important to use boxes, fittings, and closures that are designed to withstand these conditions. This may include using enclosures made of stainless steel, fiberglass, or other corrosion-resistant materials, and using watertight or dust-tight fittings and closures to prevent the entry of contaminants. It is also important to inspect electrical installations regularly for signs of corrosion or damage and to replace any components that are no longer providing adequate protection. Another important consideration is the proper grounding of electrical systems. Grounding provides a path for fault current to flow back to the source, which helps to trip circuit breakers and prevent electrical shocks. All metal boxes and fittings must be properly grounded, either by connecting them to a grounding conductor or by using self-grounding devices. The grounding conductor must be sized according to the requirements of NEC Article 250 and must be securely connected to the grounding electrode system. In addition to grounding, it is also important to provide overcurrent protection for electrical circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of a short circuit or overload. These devices must be sized according to the ampacity of the conductors they are protecting and must be installed in readily accessible locations. It is also important to ensure that overcurrent protection devices are properly maintained and tested to verify that they will function as intended. The National Electrical Code also includes specific requirements for the installation of electrical equipment in hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present, creating a risk of explosion or fire. Electrical equipment installed in hazardous locations must be specially designed and certified to prevent ignition of these materials. The NEC classifies hazardous locations into different classes and divisions based on the type and concentration of flammable materials present. Each class and division has its own specific requirements for electrical equipment and wiring methods. It is important to consult the NEC and any applicable local codes or regulations to ensure that electrical installations in hazardous locations comply with all requirements. In addition to the technical requirements of the NEC, it is also important to follow safe work practices when performing electrical work. This includes energizing circuits before working on them, using appropriate personal protective equipment, and following lockout/tagout procedures to prevent accidental energization of equipment. It also includes being aware of potential hazards such as energized conductors, sharp objects, and slippery surfaces, and taking steps to mitigate these risks. Safe work practices are essential for preventing electrical accidents and injuries and for ensuring the well-being of electrical workers. The National Electrical Code is a complex and comprehensive set of standards that covers a wide range of electrical topics. It is essential for electrical contractors, inspectors, and engineers to stay up to date on the latest code requirements and to follow safe work practices to ensure that electrical installations are safe and compliant. By adhering to the NEC and other applicable codes and regulations, we can protect people and property from the hazards of electricity. Remember that electrical work can be dangerous, and it should only be performed by qualified and licensed individuals. If you are not qualified to perform electrical work, it is best to hire a professional to do the job. This will help to ensure that the work is done safely and correctly and that your electrical system is in good working order.